Okay, so we go to the third part of this today's lecture, and the next thing that we're going to look at is how different wireless systems evolved over a period of time. Essentially, wireless systems can be divided into three main categories or four categories. Some people say four categories. Okay, so you have the first category is satellite-based systems. The second category is mobile communication systems. The third category is wireless LAN, and the fourth category is what are referred to as cordless phones. So these four categories are shown here. So you have cellular phones, satellites, cordless phones, and wireless LAN. Now, in all these four types of wireless systems, a number of different standards have been created. Okay, like the first cellular telephony system was referred to as a Nordic mobile telephone. It was developed in the Scandinavian countries, because the Scandinavian countries were the leaders in wireless communication, because primarily, if you look at the Scandinavian countries, which were countries like Norway, Sweden, and one other country, I think it's Denmark, you find that people lived in remote communities, very far from each other, in very cold conditions, and the only cost-effective way of communicating with them, between each other, was using wireless communication. So you find out all the main players in the wireless industry, which were traditionally your Nokias and your Ericssons, they all originally originated from these Scandinavian countries. So you have Nordic mobile telephone systems, and then this evolved, and then it became the GSM systems. And then on the other side of the world, in the US, you had CDMA-based systems that were more popular. And eventually you find that all of these systems, whether it be cellular phone systems, satellite, wireless LANs, and cordless telephony, they're all evolving together. And hopefully, by the time we get to fourth generation wireless systems, we will have one common framework in which you can work on any of these different technologies. So this is what they're planning to do in the future, that all these different types of systems, whether it be cellular telephony, satellite, cordless phone, or wireless LAN systems, will all eventually converge together into fourth generation wireless systems. Okay, now there's a lot of politics involved in this process. Okay, now one of the main reasons that so many different standards evolved was not more to do with technical reasons, but also to do with political reasons, because certain superpowers wanted to maintain their particular technology so that they have their dominance in the world markets. But hopefully, as time goes on, these barriers will be lifted, and we will have one common standard in the future. Now, in terms of key performance indicators, if you look at different wireless systems, when you go to industry, people talk about KPIs, key performance indicators for wireless systems. Okay, and the major ones that they use are coverage. Okay, so what is the coverage that we can obtain with a wireless network? So it's in terms of kilometers squared. Okay, what sort of coverage can we obtain? What sort of capacity? Okay, and capacity is usually represented in bits per second rather than megabits as it's shown here. The other aspect is spectrum, and more than spectrum, because spectrum is a very expensive commodity these days, radio spectrum. So how efficiently are we using the spectrum that we have been allocated? And the fourth most important KPI is the cost of the system. So these are, whenever, for example, you go on a project and you have to design a wireless solution for a particular scenario, for a customer or for a network operator or for a client, you have many different ways that you may be able to implement solutions for this particular customer. And then what you have to do is you have to evaluate these solutions in terms of these KPIs, okay? So you look at each of the possible solutions that you can come up with and say, okay, what sort of coverage can we obtain? What sort of data rates or capacity can we, how efficiently are we using the spectrum that we've been allocated? What is the cost? So these are key performance indicators that are associated with wireless systems. Now, I talked to you briefly about the different cellular systems and the fact that they're evolving. Okay, now the other aspect that I forgot to mention in this slide is that the technologies that are in light blue, which are the technologies that are probably here, these technologies were predominantly analog, and as time went on, analog technologies became digital technologies, and they are also converging together. So nowadays the standards not only talk about the future, current and future standards not only talk about how a particular system works, but how it is going to cooperate. How are you going to have systems that will enable you to maybe do a handover from a cellular phone, a cellular network, to a satellite network. Okay, or maybe if you have a cellular network with multiple interfaces, maybe an interface to talk with a cellular network and an interface to talk with a wireless LAN network, how will these mechanisms be realized in the in reality? So there's a sort of so again, this is what is meant by the fact that these networks are converging together. Now, a couple of terms that also are used in wireless networks is the term infrastructure-based wireless LANs. Okay, so this term here, which I'm just highlighting here, okay, infrastructure-based wireless LANs are wireless networks that require some infrastructure that has to be planned by somebody so that it operates. So, for example, in the case you could have base stations or access points, okay, which are installed by an operator or a service provider, and all communication takes place between a wireless device and these access points or base stations or whatever you want to call them, this infrastructure. Okay, communication directly between users does not take place. Okay, so these infrastructure-based wireless LANs are used in current wireless LANs, in cellular. All of these technologies are infrastructure-based wireless LANs. Okay, so all of the functions for a network, for a wireless network to perform its functions, a number of different tasks have to be done. Okay, there's medium access control, there is a security aspect, there's mobility management, there's handover. Okay, all of these functions are performed by the network. Okay, and all the wireless device performs is it informs what sort of service it wants and the typical data rate it's expecting, and then the network decides how much it can give to a particular user. A second type of wireless network are referred to as ad-hoc wireless networks. Okay, now in ad-hoc wireless networks, you don't have any infrastructure. Okay, the wireless device communicate with each other directly. Okay, sometimes if one wireless device has to communicate with another wireless device, it might have to go through an intermediate device for that communication to take place. So these terminals sort of build up an association based on messages that they may be broadcasting. Okay, now these ad hoc networks are also becoming very popular in the area of sensor networks, which are becoming more and more popular, and they predict that the number of sensors and the number of sensor networks will eventually overtake the number of infrastructure-based networks in the future. Now these devices that form ad hoc wireless networks have to be more complex, because here we don't have a centralized mechanism that decides how resources should be utilized. Each one of these devices that forms this ad hoc network has some power on what sort of resources it needs and it has to communicate it with the others, and they make a centralized decision, but in a distributed manner. So they are more complex. Now, the other possibility that can have is that you will find that eventually these infrastructure-based wireless networks will integrate to form a much more complex wireless network. So you could have infrastructure-based networks, several wireless networks could interconnect, as in the case of, say, for example, you may have a number of wireless LANs in an organization. For example, in UTS, you have wireless LANs in practically every building, and in the case of Building 1, you have wireless LANs, many wireless LANs in every floor of Building 1 and Building 2. So all of these different wireless LANs have to have some common infrastructure through which they communicate with each other. Okay, so you have a merging of infrastructure-based wireless network that is also taking place. Now, associated with wireless networks are two important concepts, and these concepts are given at the bottom of this slide. The first one is called handover, and the second one is called paging. Okay, now the handover is a very important aspect that is there in mobile wireless networks, but it's not there in fixed wireless networks, but only in mobile wireless networks, where the user always connects to the access point that provides it the best signal strength, or which can provide it the best service. And as you, for example, you might have noticed when you, even if you're making a call and as you travel on the train from Sydney outwards, you find out that you may be changing a number of different base stations, okay, and a number of handovers are taking place without you even realizing that they're taking place. But your call is not disrupted, okay, so there's a certain amount of mobility, session mobility that is taking place in that case. So handovers is a very important task that mobile wireless networks have to perform. Another thing that mobile wireless network has to perform is the concept of paging, where you have to know which particular network or which particular area a particular user is located in. Okay, because the user is constantly moving in a mobile wireless network, in order to find out where a particular user is located, you might have to page across a number of different cells to find out where a particular user is. And when the user receives a paging message, so you have channels that have to be continuously monitored by wireless devices, and you have to be continuously monitoring to see if any of the paging messages that are being sent on these signaling channels are destined for a particular terminal. Then it has to respond saying, okay, I'm located in this particular cell. Okay, a little bit more. Okay, now, even among the wireless devices, wireless networks, there is a number of different differences. Now, again, if you look at this graph, and you might see different versions of this particular slide, you see on the x-axis, the axis here, you have mobility. So if you want higher and higher mobility, you might have to go with technologies such as GSM or UMTS, because technologies like wireless LAN, although they provide a high data rate, their mobility is very much limited. Okay, so on this side here, you have technologies where remember when we talked about wireless LANs, we said that most of the wireless LANs have the coverage area associated with them is of the order of 100 meters. So if you go beyond that, you can't be connected anymore to that particular wireless LAN. So so you can also relate that in terms of speed. You can say if you're a fast-moving user, okay, say if you're moving in a car, the best network to which you might be connected to might be a GSM network, because GSM network at present provides, within a city, it provides the biggest coverage area. So this is a mobility bandwidth trade-off that you have. What's the message on this slide?
Data rate.
Mm-hmm. How is the data rate given here?
It increases as technology advances.
Okay, so you've got many different technologies here. What has happened over a period of time? So we moved from GSM to HSCSD to GPRS to Edge to UMTS, and then other technologies in the future. Now you can see that if you were to draw a line here, okay, it tells you how long it will take you to download some information. For example, if you were to look at a line here, okay, so if you were to look at this particular line here, the one that I'm highlighting, okay, that represents 5 minutes of MPEG video. Okay, if you were to download 5 minutes of MPEG video on a GSM system, it will take you about 80 minutes to download. If you're looking at HSCSD, maybe if you get 4 time slots, it might take you 20 minutes. If it's GPRS, maybe 15 minutes. If you're looking at Edge, it makes maybe 10 minutes. Maybe with UMTS, maybe in a couple of minutes, maybe 5 minutes. So you can see that this is what the user sees. At the end of the day, what does the average person who's using the technology see? He doesn't care about data rates and all that. Okay, that is immaterial to him. Okay, he doesn't care about the size of the terminal. Maybe some people care about how big their terminal is. But what the most important thing that they see is how long it takes to download. Okay, you know a big difference between if you've got some MPEG video that you want to download. If it takes you 80 minutes to download in one technology and maybe only 4 minutes to download in another technology, that's something that you can relate to straight away. Okay, so this is from that point of view, I think this is a very important slide because it's something that the person on the street can relate to. Okay, again another slide that shows different technologies and what sort of data rates that you can achieve with them. So here you've got data rates, and here you've got different types of services that people use, starting with transaction processing, which can be done on most technologies today, to high quality video, which can only be probably done with these technologies that are on the high end of the technology spectrum. Okay, now I also talked to you earlier about the fact that in the future there will be a convergence of all of the different networks, and this is expected in the 4G technology. So the 4G technologies, which will be primarily packet-based technologies, will have an integration of the current PSTN network, because even the current PSTN network will move to a fully packet switch network, cellular mobile networks, the internet, all of these things merged with different types of networks that we have today. Okay, so this is most likely in the next couple of years we will see the emergence of, if it's not already, in some parts of the world these technologies already exist. I think some of the leaders in these areas are countries like Korea and Japan and those countries where these kind of technologies already exist in some form or the other. In terms of a wireless network, from an industry point of view, there are different players that make up a wireless in the wireless sector. So this is you, the user, okay, and the user might be a member of an organization or a customer. You have service providers that provide services, and you have network operator. Now, in the olden days, back many years ago, maybe 10 years ago, all of these was one person. Okay, maybe the Telstra was your service provider, your operator access provider, your network operator, your third-party provider. All of that was one company. But as time goes on, you see that there is a differentiation that is taking place. Okay, so you might have different companies that might form agreements with each other and work together to provide services to different users. Okay, so somebody might be actually controlling the network access, okay, which is from the base station to your terminal. Another company might be in charge from the base station, or even from your core network might be operated by another company. A third company could be a service provider, and a fourth company could be providing third-party services which the service provider cannot provide. So there are going to be different players, and this market, the way a lot of changes are taking place here, okay, and they will continue to take place. In terms of markets, we know that the number of wireless subscribers is rapidly increasing. Countries like Finland and Sweden and Norway, which are the three countries given below here, these countries have already exceeded more than 100%. That means there are more phones than people in those countries. Okay, now how somebody can have two mobile phones, I don't know, but I suppose some people can have two mobile phones. You can see these are some statistics from 2007, from Q4 of 2007. The country that has the largest number of mobiles now is China. Okay, China has of the order of 300 million mobile subscribers, and it is also the number one country in terms of GSM. But the Philippines, or the Philippines, is whichever way you want to say it, is the number one country for SMS. I don't know why, but people in Philippines love sending SMSs. In fact, when they first rolled out GSM networks in Philippines, the entire networks crashed. And people were trying to figure out why are these networks crashing in Philippines. It's because everybody was sending so much SMS that there was no the control channels were all full. So even though there were spare time slots sitting, the signaling channels on which you send your SMS were so used up, nobody could use the remaining capacity. So that's the situation. So here are some statistics about mobile statistics. Some of you might love looking at these statistics, yeah. So, okay, the last thing that I want to chat about is a reference model. Okay, now you've all at some stage seen this reference model. You've got, if you look at the TCP/IP model, you've got the application layer, which sits on top of the transport layer. The transport layer is the one that establishes the end-to-end connection between the client and the server. Then you have the network layer, data link layer, and the physical layer. So these are the 5 important layers. Now in some texts, they will combine these 2 layers into one layer, but essentially there are 5 layers. So you have these systems here that are at the these systems here that are referred to as end systems. Okay, because and these systems here that are referred to as intermediate systems. Does anybody know the difference between an end system and an intermediate system? What's the main difference between an end system and an intermediate system?
Intermediate system is just one that transfers the data.
Okay, the intermediate system essentially are used to get the data from one end system to another end system. Okay, so in terms of protocols, what is the main difference? Exactly, it doesn't go above the network layer. Okay, so the end systems have the complete protocol stack from all the way from the application layer down to the physical layer is implemented at the end systems. Okay, because essentially it's an application at the client at one end system that is communicating with an application at the other end with another end system. So these end systems have the complete protocol implementation, whereas the intermediate systems do not have the full protocol implementation. Now this has both advantages and disadvantages, and later on when the last lecture that we have will be looking at mobile transport layer to see how we have to modify the transport layer in wireless networks to get data across from A to B. Okay, now I think all of you have come across this concept at some stage before. Whenever you've got data being transmitted from A to B, you've got some application user data that is transmitted down to the transport layer. The transport layer adds this header. Okay, it's either a TCP header or a UDP header, and then that PDU is sent down to the network layer, and the network layer adds its own header, and then the entire PDU is sent down to the data link layer, and the data link layer adds its own layer. So what is this process called? Encapsulation. Okay. So encapsulation is a process by which each protocol layer adds a header to the PDU that it receives from the higher layer. Okay, at the beginning of this lecture, we talked briefly about the concept of overlay networks. Okay, the fact that we have a number of networks that are overlaid on top of each other. So at the highest level, which is this level here, you see a network that has a very large coverage area, maybe even across the whole country. So that network could be served by a satellite network. Okay, and at a lower layer, you could have a network that covers maybe a city, a metropolitan area network. Okay, so you could be using something like GSM or UMTS for this particular task. And then you could have a campus-based network, which is maybe a much smaller network, maybe a couple of wireless LANs with some infrastructure back-end network connecting them together. And then the last possibility is some kind of in-house or personal area network with a much smaller coverage. So in wireless networks in the future, we will have a number of networks that are overlaid on top of each other, maybe operating at different frequency bands, maybe on the same frequency bands. And you will find out that there will be two types of handovers that we need. We need handovers when you go on the same level. Maybe as you're driving through a city, you might have to hand over from one base station to another base station within a metropolitan area network. So when you do a handover on the same network, those are referred to as horizontal handovers, the term that is given here. And sometimes you might have to do a handover from a network to another network that is higher up or lower down in this overlay, and those handovers are referred to as vertical handovers. So horizontal handovers and vertical handovers are going to become part of wireless networks. Now, this obviously, to do vertical handovers, you've got to, most likely you have to have a device that has a number of different interfaces, because it has to, most likely when you do a vertical handover, you have to go from one technology to another technology. So your wireless device must be able to communicate with both these wireless networks. Okay, so that's about all that I want to cover today. Now, just as a tutorial revision, there are a couple of things that, for those, most of you might have done this in some course before, but there are a couple of formulas that you need to remember from some time back. There's the concept of Nyquist bandwidth, okay, and also signal to noise ratio, what is meant by signal to noise ratio and how to work it out, and also the Shannon capacity. Okay, this formula here, where this represents the capacity in bits per second, that represents the bandwidth, and that represents the signal to noise ratio. Okay, so you should be able to use these, and I've given you, I have two questions here. I want you to spend a minute trying to work this out, and once you've done this and show me your answer, you can go home.